Hi everyone, this is the third video for section 6.3 on multiplying and dividing fractions. So we left off the last video talking about what it meant to be a multiplicative inverse, and then just the general properties of multiplication. So I wanted to talk about a little bit more what it meant to be a multiplicative inverse, just because I think it's good to see some examples of things. So if we're just dealing with a normal number, right, a real number, and if we have a real number 2, then the multiplicative inverse of 2 is going to be 1/2, because we can multiply 2 by 1/2, and we all know that we get 1, right? Essentially, just from the multiplication algorithm that we talked about before, you put 2 as a fraction with a denominator of 1, and then multiply straight across on top and bottom. And so that's typically how we think of multiplicative inverses for whole numbers or natural numbers. It's just 1 over that number. But for example, if instead we're looking at a fraction and we want to find the multiplicative inverse of 2/3, this is why it's called the reciprocal, because you flip the fraction upside down. So then we're multiplying by 3 over 2, and on the top, 2 times 3 is 6, and on the bottom, 3 times 2 is 6, and we get, this simplifies to 1. And again, this is really dependent on the commutative property of multiplication, right? Because a times b, right, we're gonna underline it twice, because a times b is the same as b times a. That's why this reciprocal works, because 2 times 3 on the top is the same as 3 times 2, which gives us that they multiply to equal 1. So this is just examples of multiplicative inverses. So if it's a whole number, you just put 1 over that number. And if it's a fraction, then you switch the numerator and denominator. Okay, so now we're going to try and use properties of real numbers to solve an equation, right? Where we have 2/3 x is 4/3. And we want to solve for x, and we want to state everything that we do. Okay. So here's what we do. So we take 2/3 x and 4/3. So the first thing that we can do is multiply by a reciprocal of 2/3. So if we take each of these and we multiply 3 over 2 times 2 over 3x equals 3 over 2 times 4 over 3. So we do this because we're trying to solve for x, which means that we just want to multiply x. We want to get x by itself on one side of the equation so that we can see that x equals some number. So a good strategy of doing that is whatever number is multiplied by x, you can multiply by the reciprocal or the multiplicative identity of that number to get 1. So the first thing we did was multiply by the reciprocal of 2/3. And now we can reassociate, which just means move our parentheses, to reassociate that multiplication in the first term or on the left-hand side, and then we have everything the same. So we reassociate. When we reassociate, we essentially just use the associative property. So here, we use the associative property. Okay, and then next, we can just multiply. So we know that 3 over 2 times 2 over 3 just gives us 1. So that's 1 times x. And then we multiply on the other side. So remember, our algorithm for multiplication is you just multiply straight across on top and bottom. So our numerator is 12, and our denominator is 6. And so here, all we did to do this was we did the multiplication. So we just multiplied. And now we simplify. So we can get x equals 12 over 6 simplifies to 2. So this last step here is simplifying. Okay, so this is one way to solve this problem. And I say one way because there's not just one way to solve this problem. This is one way that specifically uses a multiplicative inverse, but another way, there are other ways to do it. Yeah, there are other ways to do it. So another way that we can do it is like so. So instead of using the multiplicative inverse, we could clear the denominator. So in order to clear the denominator, we would multiply each side by a common denominator of a fraction, right? We have a fraction on both sides of our equation. So to clear the denominator, we just multiply by a common denominator for all of the fractions in our problem. So in this case, all of our fractions are over 3. So we could multiply both sides of the equation by 3. Okay, so we can multiply by a common denominator, reassociate, and then this just gives us 2x equals 4. So I don't have a lot of space here, so I'm not going to write out all the steps explicitly, like the word part of describing the steps, but we multiply by a common denominator, we reassociate using the associative property, we multiply, and then we can divide by 2 to get x equals 2. So this is the same way, well, it's not the same way, it is a different way to do the same problem, that both of these are correct. So the essential first step here that's different is to multiply by a common denominator. So if we multiply by a common denominator in this first step, then you can get the same answer going, just doing different steps, because right, our first step is different, which means that our subsequent steps will also be a little bit different. So we can multiply by a common denominator to get the same answer here. If you want to practice doing this, I would encourage you to finish this problem writing out all of the steps explicitly. Okay, so this is all we're going to talk about for multiplication. And so just so everything's kind of in the same video, that's going to be all for this video, and we'll start talking about division in the next video.